This is lesson 6.5b, so the second half of linear inequalities, and later on in the video will be lesson 6.6. In the first part of lesson 6.5, we learned how to graph linear inequalities. Now we need to work backwards. From an equation, we want to be able to write an inequality. Looking at this equation right off the bat, we're just going to start looking at the line. First of all, we see that it's a dashed line, so that means that my equation is either going to be a less than or a greater than equation. If it was a solid line, it would be less than or equal to or greater than or equal to. But again, since it's dashed, we will use one of these inequalities. The next thing we can look at is which form of the line I'm going to use. I see here that I have a y-intercept, and I also have a very clearly defined slope. That means that I can use point-slope form. Well, I could use point-slope form, sorry, but the easiest form to use would be slope-intercept form with a slope and an intercept, y equals mx plus b. So let's find those parts that we need. Our b, or our y-intercept, right here is 2. Our slope is rise over run. So we will go up 3, and we will go right 2. So our slope is going to be 3 over 2. We can go ahead and write the equation, plugging all of those things in. Y, it's not going to be equals, and we don't know yet if it's less than or greater than. So we'll skip that part. Rise over run, 3 over 2, x, plus our y-intercept is 2. Now we need to figure out if we want to put in a less than symbol or a greater than symbol. Again, just like we did when we were originally graphing, I'm going to look at the point 0, 0. 0, 0 is one of these solutions. So I'm going to take that point, 0, 0, plug it into my equation, and insert the correct inequality that will make this statement true. 0 is something to 3 over 2 times 0 plus 2. 3 over 2 times 0 will be 0. So 0 is something to 2. I know for a fact 0 is less than 2. So that means in order for that statement to be true, I need that sign also to be less than. And this will be our final answer. On to lesson 6.6. Now we're moving on to systems of linear inequalities. Remember, a system means that we're going to be looking at more than one equation and trying to find the solution to both of those equations. Here, when we just had lines, we were looking for where the lines intersect. In this lesson, we will be looking for where the shading intersects. Graph the systems. Our first graph, I'll go ahead and I'll do this one in red. It's clearly in y equals mx plus b form. So my b is negative 3, put a dot there. And my slope is 2, so it will be 2 over 1. I'm going to go up 2 and right 1, and that's where my next point will be. Up 2 and right 1. Our line is, or our inequality is less than, so that means we are going to have a dashed line. And now I'm going to take the point 0, 0, and I'm going to see if it fits the solution. Is 0 less than 2 times 0 minus 3? Is 0 less than negative 3? No, that's not a true statement. 0 is greater than negative 3. So that means I'm going to shade on the opposite side. I will shade where 0, 0 is not. Now we'll go ahead and graph the next equation. I want to write this equation in a form that I like to graph. Yes, it's standard form and we could graph it using intercepts, but I also see if I subtract 2x from both sides, I get the equation y is greater than negative 2x plus 2. My y-intercept in this case would be 2. And my slope is negative 2 over 1. So that means that I will go down 2 and right 1. Down 2 and right 1. And that is where my new point would be. Again, we have a greater than sign, so my line will still be a dashed line. And we're going to test out 0, 0 to see what happens. Is 0 greater than 2 times 0, negative 2 times 0 plus 2? Negative 2 times 0 is 0, so is 0 greater than 2? No, that is not a true statement. So again, I'm going to graph on the other side of the line. The solution set is where both of the shading intersects. Notice here that the red and the purple are both shading this portion. That means that this portion here solves for both the red line and the blue line. And this is what your final answer will look like. Make sure that it is very clear where the intersection is. Now once again, we need to go ahead and work backwards. Let's start with the red equation. In our red equation, we clearly see a y-intercept and 2 points that make a very distinct slope. So my y-intercept is 7. And my slope is down 1 and right 2. So rise over run will be negative 1 over 2. We will write our equation, and we have y is something to negative 1/2 x plus 7. Now if I look here at 0, 0, again that's my favorite point to choose because it's the easiest. I see that it's part of the solution. It's part of the shaded area. So I need to make a statement that is true. When I go ahead and plug in 0, 0 is something to negative 1/2 times 0 plus 7. So 0 is something to 7. Well, I know 0 is less than 7. So that means in that original equation, I'm going to want to say y is less than negative 1/2 x plus 7. Now, onto the blue line. For our equation on the blue line, we can see a y-intercept again. Our b is going to be negative 2. And looking at our slope, we see clearly between 2 points. We are going up 1, 2, 3, and right 1. So our slope is going to be 3 over 1, rise over run. Writing our equation, we have y is something to 3x minus 2. Again, I like looking at the point 0, 0. Here it's a different situation though, because here 0, 0 is not part of my solution set. So I want to put an inequality in that will make it a false statement. So 0 is something to 3 times 0 minus 2. 0 is something to negative 2. Remember, we want it to be a false statement. A true statement would be 0 is greater than negative 2. Here it's less than negative 2 because that would be a false statement. We're also going to look at our line and we see that it's bold, so it's not just less than, but it's less than or equal to. So that will be our original equation there. When we write our answer, it will be y is less than negative 1/2 x plus 7, and y is less than or equal to 3x minus 2. And that is your final answer. Lastly, let's go ahead and do a word problem. I love those. You're planning what to do after school. You can spend no more than 6 hours watching Netflix and doing your homework. No multitasking allowed. You need to focus on your homework when you do it. Your New Year's resolution is to spend no more than 2 hours watching Netflix. And your mom says that you must spend at least 1.5 hours doing homework. What is a graph showing how you can spend your time? So when I write out my equations, I'm going to go ahead and I will call X my Netflix. I will call Y my homework. And let's write some equations. I can spend no more than 6 hours total watching Netflix and doing homework. So when I add them together, they have to be less than or equal to 6 hours because I cannot spend more than that. I can spend 6 hours, but I cannot spend less than or more than 6 hours. Your New Year's resolution is to spend no more than 2 hours watching Netflix. So I can spend 2 hours or I can spend less than 2 hours. So again, it'll be an or equal to graph. X is less than or equal to 2. Your mom says you must spend at least 1.5 hours doing homework. You can spend more than 1.5 hours doing homework. You can spend 1.5 hours doing homework, but you can't spend less than that. So we will spend greater than or equal to 1.5 hours doing homework. These are the 3 equations that we are going to use. It tells us to graph it, so let's go ahead and graph it. So these were the 3 equations that we came up with in the last slide. X plus y equals 6. Let's graph this using intercepts. If I make y 0, I see x is 6, so I'll put a point at 6. If I make x 0, I see that y is also 6, so we'll put a point there as well. It's a solid line, so we will draw a line straight through since it's an or equal to. We need to graph it. Graphing, it says less than, so let's try the point 0, 0. If we plug in a point here, 0, 0, 0 plus 0 is less than 6. Is that true? Again, we're looking here. 0 plus 0, is that less than 6? Yes, 0 is less than 6. So I'm going to go ahead and I will shade this bottom portion where 0, 0 is located. Now let's go ahead and we'll graph the next one. X is less than or equal to 2. Just like with regular lines, an X line is going to be vertical. So if we're saying X is less than or equal to 2, that will be here at the point 2. It's a solid line. So it looks like that. And it says less than 2. So I'm going to go ahead and, again, use my point 0, 0. Is 0 less than 2? Yes, it is. So my solution is going to be over here, including 0. And now our last and final line. Y is greater than or equal to 1.5. So 1.5 is about here. Just like with regular ones, a y equals graph is going to be horizontal. It's or equal to, so it'll be a solid line. And it says y is greater than that. So when we take 0, 0, and we try this here, is 0 greater than is 0 greater than 1.5? No, it's not. So I'll shade on the other side of that line. And when I shade there, it'll be all up here. So again, the part that we're looking for now is where all 3 intersect. Where do all three intersect? Well, I see here it goes to this red line, it goes down to the purple line, and up to the blue line, right in between that. These are all of the possible solutions to the ways that you could combine the hours that you spend watching Netflix and the hours that you spend doing your homework. I hope that this video was helpful. The joke today is this. Why is the ocean blue? Because all the fishies go bloop, bloop,